We will work out the direction of the current in a circular loop um, carrying the current. We consider here a circular loop of wire carrying the current I as shown. We can divide the loop into a number of segments, with each segment being approximately straight. So here's the first segment, the next segment, the third segment, and the fourth segment. We will apply the right-hand rule separately to each segment and deduce the direction of the field near that segment but on the inside of the loop. For example, let's start with the first one. So in this picture, you can see that the fingers are curling in such a way that they indicate the magnetic field curling around the conductor, that part of the segment. The thumb point towards the current. Now, the magnetic field inside the loop is shown by the curved fingers, but the direction of the field in the plane of the loop is coming out of the plane of the loop. Similarly, in position 2, the thumb is again pointing in the direction of the current, but the fingers are curled in such a way that the magnetic field is inside of the loop is towards the left. And we can take this process to the other two positions, and you will see that the magnetic field is always pointing towards the left on the inside of the loop. As we can see, all of these magnetic fields from the four parts, and of course the other segments of the loop which we didn't consider, would all add up on the inside to produce a net magnetic field shown by the red arrow here, and that would be pointed towards the left in the center of the loop. There is another way in which you can think about the right-hand rule. We will use the right-hand rule just one time in this method of deriving the magnetic field. So now you hold the fingers curled in such a way that the current is going in the sense in which the fingers are curled. So if you think of this as the current going counterclockwise, the fingers are curled in the same direction. So in that case, the thumb would point directly at the direction of the magnetic field.